talking about environment separation and things like that. So what we're going to be doing in today's class is to design an architecture and understand how we make decisions when we're designing architectures, and also do a bit of overview of what a typical landing zone looks like when it comes to separating an environment. Okay, so I'm going to share my screen shortly so we can get started. And by the way, I hope you guys were able to watch the OSI model video that I shared yesterday. So if you haven't, please, after today's class, try to watch that video, because it does a lot of good when it comes to explaining what OSI model is and communication between computers at different level of communication. Okay. All right. I hope you can see my screen.
Yeah, we can.
Nice. All right. So last week we had this document. So in case you were not in class last week, I shared this document right here, and it has a link to the PowerPoint slide that we use. And we talked about a few things which surrounds architecting an infrastructure in AWS cloud. And by the way, it doesn't actually have to be AWS specifically. The same concept goes with any cloud at all when it comes to designing an architecture. And then we talked about the fact that we can have tooling environment and other business environment as well. And when it comes to making decisions about environment separation, how to ask ourselves certain questions that leads to our decisions. You know, we also talked about the network layer, the kind of questions such as how will users access the tools over the internet, and what sort of solutions in the cloud will help us answer those questions. For example, what will users type in the browser? Then when we have those kind of questions in our mind, it helps us to decide, oh, we're talking about DNS. What sort of DNS configuration do we have to make that happen? When it comes to accessing our servers, especially when they're inside private subnets, then we also have to ask the questions, how will engineers access this service? So I'm going to mute everyone so that the noise can be reduced. Good. I hope you can see and hear me as well. So if you have this document, that's awesome. If not, let us know so I can share it. So what we're going to be doing today is actually go through a typical design experience. All right. And I have another note, which is right here. And what this is going to focus on is, okay, you said you don't have the document. All right, cool. So let me just share it right now. Okay, so I can share that in here. So by the time you go through the video for last week, it will make a lot more sense to you. Okay. Now, what we want to do today is talk about our project, which is the infrastructure that we want to build. And as we're trying to build this infrastructure and design it, it will trigger some questions in our mind, and we will then try to answer those questions as we design, okay? And it will also help us talk about some of the AWS services available to solve some of the problems, and then help us to understand specifically what those services do, why we would choose a type of service over another type of service, because in some cases there are different categories of the same service, and the kind of things you have to think about when it comes to making such decisions. So if you guys can go to draw.io, so if you go to draw.io, it would result to diagrams.net. And what you can do is create a new diagram. So as much as possible, try to follow along with what I'm trying to do. I can name this AWS Cloud Infrastructure. So you can name it something like that, okay? And I'd like this class to be very interactive. AWS Cloud Infrastructure. All right, so this is going to want to save a file on your local file system. So that's why I have this. So you have to name it and save it. Okay, and then you're going to have a plain page like this. All right, so let's try. If you have two screens, that makes a lot more sense, because then you can watch me on one screen and then you can be designing on the other screen. All right. But if you don't have that, if all you have is just one screen, that's fine. No problem. Maybe when you watch this video again, it will make a lot of sense to you. Okay. So what we would like to do is let's assume, and by the way, there was, I think some people, let me open up Slack, because someone, I think 2 or 3 people had already designed this infrastructure, and I saw some of the attempts, and it looks quite impressive. Let me actually bring that up here. Okay, so this is our Slack right here. And by the way, this is the video I asked you guys to watch. So Chi Jundu already made an attempt to draw the architecture. So that's a good attempt. Let me see if I can go through the other one. There's someone else. Okay, it was the same person. Michelle also made the same attempt. Maybe I can just use this. Okay. So what we are trying to do here is, yeah, wait a minute. Okay, maybe we can use this. So there is a task that's been shared. And if you have attempted that task, you would see that we've painted a number of scenarios. So we have a scenario with a fintech company, a distribution company, and I think the third one is a healthcare company. And what we're trying to do with this is to help you prepare yourself ahead in case you eventually get to work with any company in these industries. And the ask is, we have a project to deploy a number of applications. Okay, so these applications will run across multiple environments. So we have the dev environment, the QA environment, the SIT environment, the pre-prod, and the ultimate production environment where our users will access the product. Just like Diary.io, for example, we have our production environment, which is the one that everyone interacts with at Diary.io. But we also have our non-production environments, like for development, for QA testing and all that. And that's where internally we have to test our product very well before it goes all the way to production. And taking it to production also means that there are some automated processes that it goes through, and that's where CICD comes in. And we need tools for CICD. Remember last week we talked about some of the tools for the different DevOps cycle, right? So the development phase, we have tools required for that, for the build phase, for the planning phase, for the testing phase, and all that. So our CICD requires a tool, and some of the tools available in the market will be Jenkins, GitLab CI, GitHub Actions, so whatever tool it is, it doesn't matter what tool it is. What matters is the fact that we need to do some automation to take our product from building it, from coding and building, from developers all the way to production. Okay. And when we get to production, there are other things we need to do. So as our customers interact with our products, we need to monitor it. We need to operate it, right? So operating it means when there are issues, there's a team in charge of incidents, and they are able to act on the incident when they occur. Monitoring means that we are able to understand when there is a CPU spike or a memory spike, or when the disk space for our databases is filling up, and we're able to act as these things happen. Okay. But we need tools to also monitor our infrastructure, right? And so we need an infrastructure that not only supports our business applications, but also supports the tools that we need to power our infrastructure, right? So what our infrastructure design now is asking us to do is to design something for our tooling where all the different tools is going to live, and then our business applications and how we get to connect both together. Okay, so for example, one example of a tooling application is the ELK stack. And ELK represents Elasticsearch, Kibana, and Logstash. And we'll talk about what each of these tools do, but as a stack, it's called ELK, which is ELK. Now, the ELK stack needs to be installed and configured somewhere to work with our infrastructure so that logging can be implemented. So when we talk about logging, we're talking about the different logs that goes into our application. When you go to the browser, you access an application and you try to log in, every action that happens on the website gets logged. So consolidating all the logs together in a database, that's what Elasticsearch does. Okay, so it's a document database that is distributed and can scale to whatever length or size. And so we need to install and configure it somewhere so that it can work with our applications. Okay, so what our architecture is asking us to do is to design something that shows how the different environments will be configured and how they sort of work together. Okay, and I can see some of us have attempted those projects, and this is what I'm showing you. So what we're going to do in this call is actually to try to design that infrastructure from scratch. Okay, and we'll do it together. And also what we would like to do is to give you what the thought process is when it comes to designing an infrastructure and how you will make some decisions around it. Okay. All right. It's just a little bit hot in there, so I'm just putting on the AC. All right. So the first part of the infrastructure will focus on the tooling part, and that's what we have here. So tooling, this is where we will install tools that will support our entire infrastructure. And there are different categories for our tools. So for this particular company that we're working with, it doesn't matter whether it's in fintech or healthcare or whatnot. We have tools for CICD that we require. Okay. And each of these tools will have to be installed on some servers, right? So for CICD, we're talking about Jenkins. We need to install Jenkins somewhere. Nexus is an artifact store. So for every build of our code, we need to store the artifact somewhere. Okay. And for those of you that already know about containerization, we're not touching containerization yet. Everything is going to be based on EC2 servers right now. Okay, so when it comes to monitoring, we have tools for monitoring. So Grafana, Prometheus, these are some examples, and you're going to see them in action when we install them and what they do. And what they actually do is, for Prometheus, for example, it extracts metrics from every server or every service that's running. So how your applications are using CPU and memory and all that, it basically extracts that data and stores it in some time series database. And then Grafana is the visualization tool. So we need to visualize what's going on, create bar charts and some pie charts or whatever charts that can help us see that, oh, on server X, we're using this much memory or this much CPU. And because of certain actions, maybe there's a lot of users using our system right now, it's spiking up things. And that's visibility will help us to decide when we need to scale or when we need to take certain actions. So it helps us to become more proactive rather than reactive. Because reactiveness is when something breaks and we react to it. But we're proactive when before something breaks, we know that something is about to happen, and before it happens, we're able to take action and the users do not eventually know what's going on. And when it comes to logging, which is a critical component of monitoring as well, or observability, which is another way of looking at it, being able to observe our infrastructure, we have a number of options, but the tool we're looking at here is ELK Stack. And the E there stands for Elasticsearch, the K there for Kibana, and L for Logstash. Elasticsearch is the database side of things, which is where all the login information is stored. The Kibana side is similar to Grafana, which basically helps us with visualization. We're able to visualize things, all the charts and all that. And then the Logstash, think of it as the filtering part. So sometimes it is not all the data that we want to go into Elasticsearch. So with Logstash, we can filter things and say, well, we don't need to log every action that's happening. These are the ones that we're interested in. One with Logstash, we can put in some filtering logic in, and based on that, it's only the filtered data that goes into Elasticsearch. So think of Logstash like that. So it helps us with the injection part into Elasticsearch. Okay. All right. So I hope you guys have the draw.net, diagrams.net open. And what we'll be doing is we are going to play the role of a solutions architect that has been given the responsibility to draw an architecture, and is going to think through and begin to design things so that ultimately we have an architecture that the DevOps team can then take and start to implement. Any questions so far? All right, cool. No questions. Okay, so I put these three things here, which is basically a follow-up on what we had before. So networking / security, compute, and data. Always think about those three, So when it comes to networking, we're thinking about, how will users access the tools over the internet? What will users type in the browser? How will engineers work on the servers? What will restrict access from unwanted, unwarranted visitors? Everything that talks about security and networking, that's the kind of thing we want to think about. So when we're drawing our architecture, we always want to think about each of these things as we go along. So the first thing you want to do is, there's this rectangle thing right here. We can drag that in here. So you can click on it, drag it in, and basically expand it like that. All right. And I can do copy like this and paste, and you can duplicate as well. Okay. So we have these two, and this is just to tell you basically that you can have multiple things. So if you don't duplicate, you can have one and work within one place. So for now, let's focus on one, and this one is going to represent our entire infrastructure. Okay, so you can just carry on with me and let's follow along. Okay, so I'm just going to make it a little bit bigger. And what this represents is our entire infrastructure in the AWS network, So what we're doing is building out an infrastructure. Without AWS, if we go back in the days, companies have their own data centers. Okay. Companies have their own data centers, and this would have been a representation of a physical data center. Like a data center is just a physical place that you can put your computers. And then within there, you can have different technologies that helps you network those computers together. But that's exactly what we're trying to simulate here, except that it's happening in the cloud. Okay. All right. So, and specifically, we're talking about AWS cloud here. All right. So this is our infrastructure. But one thing we also want to do is let's see if we can search for something now. I'll put a globe here. Okay. So let's see. We could just pick up anyone here. Which one do you think we should take? Internet globe. Okay, this looks nice. So we just drag that. And what this basically represents, this is just going to represent for us the fact that we have to go through the internet to access this infrastructure. Okay, and so this represents our clients. All right. Or if you like, you can even maybe just let me see if we can find an actor. Okay, so this is an actor. Maybe we can just put an actor here. Okay, to represent a potential actor. So this could represent our customer. All right. And we can maybe have another one. This could represent our engineers, because the kind of people that needs to access the infrastructure will either be our customers or our engineers. Our engineers are our DevOps engineers, our developers, anyone that needs to interact with the infrastructure. Okay. All right. So we have this. So everyone will go through the internet. I can draw this like this. Let me see if I can find a way to make it look a little better. Okay, there we go. All right, so engineers, customers, everyone goes through the internet, and then, oops, let me make it a little smaller, and then connect to our infrastructure. Okay, so this is our infrastructure right here. All right, the next thing is, well, AWS will create what is called a VPC. I believe we all know what a VPC is, which is the virtual private cloud, right? So the first thing you want to do is create a VPC, and then within a VPC, you put in all your resources in there, right? So let's say, okay, VPC is the first thing we want to look for. Let's see if we can find an icon for it. So this is for VPC pairing, VPC NAT gateway, but this is actual VPC, so we can drag that. And then we can maybe make it a little bit smaller. And then we can just put that right here to show that this is our VPC. And you can double click on that. Let me see if I can double click on it and just type VPC. Okay, cool. So we have a VPC. So that means over the internet, we're connecting to our infrastructure. And the very first thing we get to do is to create a VPC. But one thing you have to bear in mind is this VPC is private within AWS. Okay, it's one thing to connect to the AWS console like this. You can see here, I'm just logged in inside. And then in here, I can go ahead and go to the VPC section and create a VPC. But the fact that I create a VPC here, okay, this is a very new account, so that's why this is coming up. Okay, let's go to the, okay, cool. 1 second, let me just bring that back. Oops, it's coming back. Okay, don't worry. Let me bring that, take that away. I have another AWS account I can show you right here. So VPC. Okay, so this is VPC right here. And the fact that I can click this button to create a VPC and get all the VPC configuration going and configured, it doesn't mean that that's how our customers will be able to access this, right? Our customers will need to go through the browser and access whatever the website is, you know. So I'm going to diary.io. Let's assume this project is for diary.io. Our customers will go through a browser like that. So you as the engineer, yes, you have access to AWS console to create the VPC, but your customers will not have access to the same thing. Your customer will have to go through the internet. So because they have to go through the internet, it means that after creating the VPC, which by default is going to be a private network, there has to be something that would allow our customers to be able to access this network over the internet. And that's what the internet gateway is, therefore, internet gateway. So if I search for it, there is something called the internet gateway, and that's a software component in AWS that allows anyone at all to be able to access the internet. And this can be attached to a VPC. If it doesn't get attached to a VPC, no one can access this network over the internet. Okay? Internet gateway. And this, let me do that, okay, and duplicate that and turn it around. Okay, so this is what allows inflow and outflow of network in and out of this network. So if you need to access any resource within this infrastructure, you need to have an internet gateway attached to the VPC, all right? But also, the servers that you configure inside the VPC need to access the internet as well. You know, if you want to do a sudo apt install nginx, the software that needs to be installed needs to come from somewhere over the internet. So let's say this is some server here, nginx repository. Okay, this is where the software code for nginx lives. And if you have an EC2 instance right here, and you want to install nginx on here, this server needs to go over to the internet to pull the nginx binary to install it on there. Without an internet gateway like this, it won't be able to access the internet. By the time it hits this, it's going to be blocked and it won't be able to go out. And that's the reason why we need the internet gateway, okay, to be able to allow traffic to flow in and out of the VPC. All right, cool. So we're getting there gradually. So, so now that we have internet gateway attached to the VPC, what we also want to think about as far as networking is concerned is, well, actually, let's go back to our notes and see from last week's note. The first one here says, how will users access the tools over the internet? So we've talked about internet gateway. And by the way, we have a number of options. We could also use VPN, especially if we're not talking about our customers, if we're talking about our engineers. So, our infrastructure here talks about our engineers. It could be that the use case we're trying to simulate right here doesn't actually require the internet to be open to the entire internet, and even though, yes, it's going to go through in the internet, but if we want the traffic to go through a secure private channel that is not available to everybody else over the internet, we can use what is called a VPN, which basically means that, imagine if we have our private data center here. Okay, so this is AWS data center, which we are renting, because that's what public cloud is all about. We're renting a space from somebody else's infrastructure. But we can have our own infrastructure as well. It's just because our own infrastructure does not scale as much as AWS infrastructure scales, because AWS have data centers all over the world. Okay, but if our company is based in Lagos, let's say it's a Nigerian startup and it's based in Lagos, and even though it's a startup that is focused and based domiciled in Lagos, it could be a product that is available all over the world, which means customers are in United States, in India, in London. For our customers to have the best experience, then we will need to go into these countries and have data centers there. Okay. And every time a customer in those local location needs to access us, they would access our servers in the region that is close to them. But because that is just not feasible, to go to different countries and start creating infrastructure, that's why we use a solution like AWS Cloud, which already has data centers in many locations all over the world. But it doesn't stop the fact that we have our own data center in the region where we're located. So we can have our data center here. And if this is where our engineers are working, that means this engineer right here is going to be coming from here. Spring to front. Oops, let's take this to the back. Okay, so that means these are engineers will come from here. So if this engineer right here needs to connect to the AWS infrastructure, thinking that we now have an infrastructure in maybe London, in United States, we need to be able to securely connect to this infrastructure. So one option will be to go through what is called a VPN. And that way, it's going to be a secure channel that even this customer will not be able to get by. So there are specific configuration that we can go through to have this kind of configuration, so that even though it's going through the internet, it's privately secure, and then we can access our VPC. Okay, so that's an option right there. So all these things, we think about them, when we're trying to answer this question. So if this is an option for our engineers, then we put that here, and our architecture will look something like this, right? Okay. So let's just leave that as is for now. Okay. And then there is the routes table and routing configuration. Okay. So now let's say we want to now have a route table. Let's see if there's something. And by the way, not every time you search for things like this that it will be available. So anything that is available, you make use of it. If something is not available, that's fine. You can use one of these icons right here. So for example, we have the miscellaneous. There are other things here. We have the advanced. You can click on this basic. So there's a whole lot of things you can just look. Whatever makes sense to you, you can use it. So I've searched for a route table, and sure enough, we have something. So we can drag it. And as you can see, a route table is just a table that holds information. So there's something called the route table. There's something called the routing. Okay. So the routing basically has to do with how data is going to flow. It's a table that holds information. Say, for example, let's use our customers, for example. If our customers need to access our infrastructure, how will data flow and where will it flow to? That information gets stored in what is called a routing table. Okay, and each of the entries in that routing table is called a route configuration. So we create a route configuration and we store it in a routing table. Okay, and then that routing table gets attached to what is called a subnet. And that takes us to the next level. That's okay. Now we're talking about subnet. We have a VPC. How do we subdivide these entire VPC? Because this VPC right here, as you can see, will have a CIDR. So let's say this is 10.0, well, 10. We use 0.0.0/16. Okay, let me just drag this to the side so we get to see more. So this /16 CIDR means that we have about 65,000 IP addresses. So that means with this entire VPC, we have about 65,000 servers or services that can have an IP address. Okay, is there anyone here that is completely new to the concept of IP address? I don't expect that to be the case, because this is supposed to be an intermediate/advanced class. So if you're hearing IP address for the first time, then you shouldn't be on this call. Okay, so I hope that makes sense. All right, so we have this much number of IP addresses, and we can actually subdivide that so that we can segment our infrastructure into a specific networking subdivide. Okay, so let me drag some things here. So let's say this is one subnet. Okay, let's say this is another subnet. Actually, what would make sense is if I just create this and then copy and paste. Press paste. I don't see paste, but I could just do Control V and then use my arrow to drag it to the side. And I could just drag it like that. Okay. So if you notice, this line in between shows that they are of the same level. So that helps us to align them properly. Okay. So within the VPC, we can have different subnets, and I can even create a few more. Have another one here. Have another one there. So that means these 65,000 plus IP addresses, we can then have them like, these subnets can be, let me just drag, this is text. So I can just drag this text right here. So this can be 10.0.1.0/ we could do like /24 or something like that. Okay. All right. So we're subdividing this network, and so this is .1. This can then be .2. Okay. And this can be .3. And this can be .4. Right? So what this means is now we have this subnets subdivided, but one good thing about the way that AWS works is the fact that this VPC right here can be located in what is called a region. Okay, a region is a physical region. Like geographically, you can have a region in, let's say, United States. In the United States, you can have a region in North Virginia, and in North Virginia, you can then have data centers in different places in North Virginia. Or say, for example, in Chicago, you can have different physical data centers within Chicago, right? Or for those who are in Nigeria, we have Lagos, we have Nigeria. We also have Abuja. So Nigeria could be a region, and then in Nigeria we can have a data center in Lagos. We have another one in Abuja. Similarly, in United Kingdom, we can have a region in um, Dublin, and then in Dublin we can have different physical locations. That's the concept. So this VPC right here could be in a region, assuming this is Nigeria, okay, and then we can have a physical data center in Lagos, right? Unfortunately, Amazon doesn't have any data center in Nigeria. So I think the only one in Africa right now is South Africa, So, but you get the whole idea. So each of these subnets would represent a physical data center within that region. I hope that makes sense, okay? All right. So since we have this physical region here, it means we can deploy our services in here, and for scalability, we can replicate the same in another physical data center. So if this was in Lagos, this can be Abuja. And what that means is that if this whole data center fails, this will be up and running. I mean, the chances that two physical data centers will be down at the same time is rare, right? So this helps us to implement high availability. And that's where you now start hearing things like availability zones. Okay. So this will represent an availability zone. So let's just put it there. So let's say this is EU. So this could be EU West 2A. Okay. All right. So that's what that means. And this region, this VPC, EU West 2. Okay. So EU West 2 represents London region. So we can have EU West 2A, 2B, C, and whatever. Yeah. So this is EU West 2B. And this can be it's 2C. I don't know if they have up to 4, but most of the time it's usually 3. But they can be more than 8. There are some that have up to 4 or 6. So let's assume this get up to 4. So you can have different physical data centers. Just like you will have your private data center. And by the way, this is also called on-prem. Okay, if you have like an on-prem like that within AWS network, these are on-prem to AWS. But because we are renting it, it's not ours. It's a public offering. So it's not our own, So it becomes a public data center. But it means that we can use some of the data centers available in AWS, and then we can deploy our services within there. Okay. So this is what our architecture looks like so far. And what this means is we can then have routing tables that get attached to, let me see if I can bring this forward. To front? No. Oops. Let me bring it. Okay, let me just put it in between and see what happens. Okay, there we go. All right, so we can have that. In fact, what would make sense actually is to give this a color first of all, so we can begin to put colors. So let's say, okay, so this has a color, and then if we send to back. Oops. Doesn't quite do what I want. But anyway. Let's see. Okay, I think that works. All right, cool. Oops. All right, so we have this route table now. And this route table, what's going on is this routing table has configuration that says that attach the routing information that has this internet gateway. Okay, actually, even though this internet gateway, we attach it to a VPC, what I'd like to do is, for the sake of explanation, I'll just make it a little bit tiny. Let me see what it will look like if we bring it into here. Okay. I'll just drop it in here for a second. And what I want to explain here is this. Without this routing information that has internet gateway configured to say that for traffic to flow from the internet all the way to this network and hit this subnet, use this internet gateway. Okay. And this internet gateway configuration is actually entered into the router table. Or maybe what we can do is have our internet gateway here, but then we can just draw an arrow that goes into this route table. Okay, so that way it shows that we have our internet gateway configuration inside this route table. That actually looks a lot better. Now, what this means is that this subnet automatically becomes our public subnet. So any subnet that has a routing table configuration that defines that network traffic can hit this subnet, it means that if you're coming from the internet, you can access whatever is here. It makes this subnet become what is called a public subnet, which it basically means that this subnet is no longer private. It automatically becomes public. You can access it from the internet, and any resource that we put in here, if we put an EC2 server in here, so this is EC2. If you put an EC2 server in there, this EC2 server can be accessed from the internet, and it can also go to the internet and fetch whatever it wants. Okay, and so this subnet right here can be tagged as our public subnet. But before we do this routing configuration, any subnet that gets created is naturally a private subnet. It means no one can access it. It's just private. It stays within this AWS network. The fact that we have a routing configuration, okay, that attaches this internet gateway to it, okay, that tells us that yes, this internet gateway is attached to this VPC, and you can use it to access whatever is in this subnet, then that subnet becomes a public subnet. Okay, I hope that makes sense. Let me see if there are questions. I'll just look at the chat quickly. Okay, so Shayi is asking, as this architecture is safe to say we can have our subnet in multiple AZ, will that not lead to latency issue? So is asking whether this is going to cause latency issue if we have a multi-AZ scenario. So the latency issue you may be concerned about here is, let's say, for example, traffic needs to flow. Let's say, for example, okay, let me just draw an arrow. So let's say, Okay, so this is one AZ, this is another AZ. Let's say traffic needs to go from here, hits this public subnet, but before this public subnet can return data, let's assume this subnet is where our database is. It goes to another availability zone and retrieves data, and then sends it back. Yes, of course, this is going to have some latency impact. No way. No, there's no doubt about it. This will definitely have some latency impact. But what we're talking about here is we're talking about high availability. Okay. So when traffic goes into this subnet, if this is where the destination is, it basically just sends the data back and we're fine. The reason why we're having multiple AZ is because if for whatever reason this data center goes down, everything we have here is replicated here. Like this routing table also exists here. And because we will have some kind of load balancer, if traffic no longer responds here just because the data center is down, traffic will no longer route there, traffic will go there. So we're not talking about going here and then retrieving data from here, which of course will lead to some latency considerations. What we're talking about is the fact that we're trying to have what is called redundancy. So we will have redundancy. We have servers here. We also have servers here. If this server is no longer responding, the servers here will respond because it has exactly the same configuration that is here. And our customers will not know that there's something wrong. They will always receive response. The service will always be available. So that's what we're talking about here. Okay. But if we're talking about latency as well, let's say our architecture is such that it needs to go to another subnet to pull data because maybe that is where our database is. Yes, there will be some level of latency, but trust me, because this is AWS, a lot of things are highly optimized. You won't really feel the latency we're talking about here. Okay. They are actually optimized for scale, for performance. Okay. All right, let me just have a look as well. Okay, cool. Let me see if there's any other question. Okay, cool. All right. So it looks like we're good so far. All right. So what we now have is we have a public subnet here. What we'd like to do is, because we have an AZ here, we have an AZ here as well. What we're going to do is we'll just replicate the same thing. So what I would rather do actually is delete this so that once we're done with our design, I can just copy it and paste it. Okay, because basically this infrastructure is just going to be designed for scale. And don't forget, we're going through we're just talking about the network layer for now. We'll still go through the compute and scaling and stuff. Okay. All right. So the next thing is, how will user type in the browser? So we're talking about DNS. So this is our internet. Customer tries to go to, let's say, the customer wants to go to Jenkins dot tooling.dare.io. Let's say that's the company. Okay. So actually, this is well, in this case, because this is our tooling infrastructure, right? So putting customer here may not actually be an ideal thing because the only type of people that needs to access this infrastructure is our engineers, for our tooling, for our monitoring and stuff. So maybe customer is probably not going to be an ideal situation here. So we can put in here for our engineers to access the servers. So we have Jenkins here. So we can also have for Grafana tooling.barry.io. Okay, So for Grafana, if they need to access our Grafana, so all of these is what the user is going to type in the browser. But you can't just go to the browser like this and just type that in and expect something to happen. This is a human readable name that no computer understands except you put some configuration in place that will help it to understand. Okay, so there is something called DNS that allows us to translate human readable names into IP address, because computers understand numbers. A computer will have an IP address, and if you knew the IP address of the server, you could put it in the browser and that will actually work. I mean, let me see if I can open something up. So for example, if we do a dig on, let's say, google.com or maybe facebook.com, right? It shows us that Facebook resolves into an IP address and there's an A record. So with DNS, there are different types of records. An A record is when you translate a human readable name to an IP address, okay? But let's see if this will resolve in the browser. So if I take that IP address and put it here, let's see if it, okay, it actually doesn't go somewhere, but let's see if we can do the same for, let's use host. So it resolves to the same. Okay, they also have IPv6. Let's see if this will work. And I'll tell you the reason why in some cases it's not going to work. Okay, so that doesn't resolve there either. Let's try that. So we have a number of IP addresses here. Okay, well, this is actually going through this. You can see this is going to CloudFront, and I'll tell you the reason why this is happening. It's just because in most cases, the human readable name you're seeing is not actually going to resolve into if the actual computer that is hosting the website. Had it been that we have just one server, okay? If we had just one server that the application is installed on, is someone trying to ask a question? Okay. So if we had one server that the application is installed on, and that is what the DNS is resolving to, then we will hit that server directly and it will render the web page. And I'm sure you guys have actually done that in some of the projects in the past. But because enterprise infrastructure will not just go to one server, there are proxies in between. Okay, so there will be some load balancer, and in most cases, there's going to be a lot of hops, from one load balancer to a reverse proxy, and before it ultimately gets to the actual server. And that's the reason why, in this case, we're hitting CloudFront. And as you can see, for Dairy.ai, we're using CloudFront, which helps us to cache data across on different edges. Okay. All right. But you get the gist, you get the whole idea. So the whole idea, what we're talking about is we need some DNS that will translate this human readable name to an IP address. And in AWS, the DNS service that does that is Route 53. Okay, so let's see if there's an icon for Route 53. That doesn't seem to be any, but let's see if there is for DNS. DNS. No. Okay, that's fine. So what we can do is we can just put here Route 53, and we can just stick that somewhere to say, okay, at the edge of our infrastructure, we're going to have Route 53 here, so that whatever our users type into the browser hits Route 53, and then it translates that human readable name to some IP address. Okay. In some cases, it wouldn't even translate it to an IP address. It would translate it to another human readable name. Except that in this case, the human readable name is going to be very long, and it's not actually that human readable, because within AWS, they just create a very long random name, which most load balancers have. And in that case, that's when we start talking about different types of record. So there's a record that translates a human readable name like this directly into an IP address. But if, let's say, for example, grafana.tooling.io needs to be translated into something like AWS dot some random text dot maybe some numbers dot AWS dot Amazon.com, you can see, even though it's still somehow human readable, right? But it's very long. It's not something that you can really remember. So if we had a load balancer here that has this address, Route 53 will create what is called a CNAME, which is going to translate this into that. Okay. So it's not it's not what's it called? It's not an IP address. So if it was something like 192 dot that, some number, then this will be an A record. Okay, so take note of that. But all that translation is done by Route 53, which is a DNS service. Sounds good. All right, so take note. Remember last week I mentioned something that every new word that you hear, every terminology you hear, make sure you have a notepad that you're writing them down and you're taking notes. Okay, you're taking note of them, because that's going to be helpful when you're building your CV, and when you start looking for work. When you're asked questions around this, it's not going to be new to you, and you're going to be able to say something about them. Okay. All right, cool. Thanks, Fred. So Fred has just put in there some of the common DNS records, and you get to understand that with DNS you can create different records, and there's a name, there's a record, there's C name, there's MX, NS, and all these different records. The ones you'll come across most commonly will be the A record, the C name, and MX record, as well as NS record, which is name server record. The other ones are not quite popular, and also the TXT record. Okay, and as we go along, we're always going to come across DNS. So there's always going to be reason to understand how these records work and why we need them and when we need them. At least now you understand why we need them, but when actually we need them is another thing. Okay, that's my bell. So don't worry, you can ignore me. Someone's going to get the door, right? So let's just carry on. All right, so let's have a look back into our question. So still on the networking layer, what will users type in the browser? We're able to answer that question. And then the question is, how will engineers work on servers? So when it comes to, for now, we have a public subnet, but most likely we're going to deploy our services in a private subnet, because the reason is we don't want to put our Elasticsearch or Grafana or whatever tool in our public subnet, just because if a bad actor is coming from the internet, so let's say this is a bad actor. Actually, let me see if I can find a better icon for it. No, we don't have an icon for a bad actor. Let me see if there's something like enemy. Is that? Nah, that's nothing. All right, don't worry. Let's say this is a bad actor, a hacker. Okay. This guy right here is a bad guy. We don't want him in our network for whatever reason, because he's here to steal data. Maybe because Elasticsearch is logging all sorts of information, our authentication information, users from all over the world trying to access our servers, hitting our Nginx servers, everything is being logged in Elasticsearch. And this person knows that we have Elasticsearch running and wants to access it so that he can extract data, which he can potentially use to formulate an intelligent track to then attack us, because in Elasticsearch, all the login information, the name, the IP addresses of our servers, where they are, there's a lot of information that can be extracted. So this guy wants to hack into our system. Imagine if we had our Elasticsearch running here. Okay, if Elasticsearch was running here and somehow this guy is able to hack in and access Elasticsearch, and he's able to steal data. He's stealing our data. Ooh, it's going in and going out. Okay, and that's because he's able to go through the internet. Obviously, because the internet is accessible to everyone, he knows about grafana.tooling.io, and somehow maybe he used to be a staff of Dire.io. He's not happy with us. Maybe we're owing him 1 year of salary. We don't do that, by the way. And he's just not happy with us. He understands our systems. He knows our password, and somehow is able to hit into our servers. And he's able to go over the internet and get that. And he's able to extract data to then attack us. Okay, that's not good. I mean, our investors will not be happy with us that happens, right? And so what we don't want is to make it easy for people to just go over the internet and access us through the public subnet, because this subnet is public. Literally anyone can access it. Seriously, like if you go through the internet, put in the browser address, okay, there are things that you can do that you can hijack the shell and even get into the Linux server that this is running on and do all sort of things. You can do SQL injection, you can inject scripts. This could be a very smart hacker that can write some script that then runs a script on the server and ultimately steals data and post the, export the data somewhere else. Like he can even do it in such a way that, the data can come from here and go to another. No, this is not EC2. Maybe there's another server here. Okay, he can actually hit this and run some script that sends data here, and from this server he can then go and do other attack and go there's a whole lot of smart things that can happen by all these bad guys. So what we want to do is, rather than put our servers or services in a public subnet, we actually want to put them in a private subnet, so that first of all, you can't even hit it over the internet. Even if you have the address, if you try to go through the internet and you hit this public, you're not going to find anything here. It's not here. What you're looking for is not here. So that's why most likely we're going to want to put our service inside a private subnet. Okay, so all right, so you get the point. That's the reason why we're talking about it. So let's go back to our notes. And here we're saying, how will engineers work on servers? Okay, so if our services are running in a private, what's going on? Sorry, I just wanted to move this. Okay, so if Elasticsearch is running in a private subnet like this, okay, then if a bad guy cannot access our service, well, the good guy that we need to work on our service, how is he going to be able to access it? Okay, so we need to be able to find out a way to ensure that the good guys are still going to be able to access, and that's why we have what is called a bastion server. And apart from a bastion server, there are a number of solutions that Amazon has made possible such that we can still access services in-house, So for example, we can use, there's a session manager. So from within AWS console, you can click a button and it opens up a shell in the browser. So that means for you to access that shell, you must have logged into AWS, right? So that's a hop. The more hops that you have, the more secure potentially you have your infrastructure secured. Unlike just one hop to get into the private subnet and the public subnet, and then there you go, you have access to Elasticsearch. But the fact that you get into this bastion server right here does not actually mean that you have access here, because whatever password you had to get here is not going to be the same password you're going to need to then get here. So our engineers can have a way to get here, first of all, right? Okay, because they're able to go through the internet, they can reach this bastion server. So this is our bastion or proxy server. So anything, whenever you hear proxy, is like a layer before the final destination. Okay, so you have a bastion here, and then from bastion, you can access the actual service that you're interested in, which in this case is our Elasticsearch. Okay, or whether it's the Grafana or whatnot. Okay, so this way now we have answered this question from our architecture. So we now have an architecture that says, well, our engineers go through a VPN tunnel, they hit the internet, they hit our bastion, and then once they get into the bastion, they're able to get in here. Now, you don't necessarily have to have bastion. So your architecture may not be a bastion. It could be the session manager, okay? And then there's something called the instance connect as well. So instance connect. So whatever it is that you choose to use, at least you have a way that you can access this service, through a proxy. And by the way, you can access this here because it's within a public subnet. So this is going to have an IP address. So using the SSH protocol, so because you want to access the server, you can just put SSH here, so yes, the SSH is going through the internet as well. So you can have your SSH, maybe the username is Ubuntu @ the @ right there is going to be the address that this has been configured for this service. Okay, so for Grafana, for example, it could be something like Grafana. Actually, it could even be something like Bastion. So you put this into your SSH and then it will route the traffic there. Okay, or it could be, if you're not using Route 53 to translate it into an IP address, you can just put the IP address directly and you'll still be able to access the service. So once you get onto this service, then you can do another SSH into the destination server that you're going to. Make sense? All right, cool. Any questions before we go ahead? All right, no questions. Brilliant. Okay, so let's quickly have a look if there's any other questions. So what will restrict access from unwarranted visitors? So again, let's say this is our guy, again, our unwarranted visitor, and he's coming from, maybe his server is trying to hit us, and he's coming from 31.54.57.89. Okay, this is the IP address of this guy. Okay, so we can actually put in some controls as well. So there's something called the NACL, which is the network access control list, which can be used on the subnet level to restrict a certain IP CIDR. Okay, so we can restrict on the subnet level and say, well, we know that our engineers are coming from, let's say, from our data center. So this data center right here has its own IP range. So if the IP range is, let's say it is 10.2 dot that dot, what's that? Okay, /24. Okay, we know that this is our address coming from this private data center. Okay, in this case, there is no, there's no need to open it up to the entire world. We can pretty much just put a network firewall. Let me see if we can have a design firewall. Okay, so firewall, generic firewall. Okay, so we can just get this. Okay, and then we could just give it a name and say NACL, because that's the firewall on the subnet level. Okay, so NACL is firewall on the subnet level, and basically we could just put that here. We can even put it maybe here to say that we have a firewall on here that only allows, let me copy this. Okay, it only allows traffic from here. So this is one way to protect every subnet. So basically, even though we put it here on the public subnet right here, remember this is one availability zone. We're still going to duplicate it and put it here. So that means the same configuration is going to go there. Okay, and in the case of our private data center, we know that the only place we accept traffic to come from is this subnet, and this subnet has its own IP range, which is 10.0.1/0/24. We can put another network access control list on this subnet and say only allow traffic from here. So we are fully protected here. Okay, so if this guy knows our password, has all that information, he's never going to be able to access this place. So that's another control that we can put in here. And as you can see, our architectural design is becoming a lot more solid with this. Okay, so we have an option here to say firewall on the network level, which is the NACL, but we also have firewall on the resource level, which is the security group. Okay, so this is where you have to understand the particular use case of what we're trying to design, because this is for our tooling infrastructure. It may not be the same for the business infrastructure that is going to be open to a lot more people over the internet, right? And so NACL may not be the ideal solution at that point, because we're not going to block out everybody else for our business applications. We still need everyone over the internet to go to Dario.io or any other website that we're building this infrastructure for. So what we can do is to use security group in that case. So you can see how the different use cases are coming to play. We're building this for tooling. It's only going to be used internally within the business, and NACL makes a lot more sense because we're blocking everything from the subnet level. Okay, so, but again, that doesn't mean that we cannot still combine both NACL and security group. So we can still have security group configuration on each of the services, especially when we want to start connecting things together. So for example, connect a load balancer with an EC2 instance. We can still restrict access to ensure that only traffic from this load balancer gets to access this EC2 instance. So you can see all the different layers of security that we're going through, which even further makes it a lot more secure. And you can imagine if this was for a fintech company, which has to comply with certain regulations. If you don't put all these tweaks in there, it can fail an audit when they come in to check what your infrastructure looks like. But by the time you have all this put in place, you don't have you don't have to worry, because it's definitely going to pass the audit, at least from this perspective. Okay. All right. So we've sorted that out. And then the next thing is, how will services in private network access the internet? So that's another thing. So we have our EC2 instance here that is hosting the Elasticsearch or Prometheus or Grafana or whatever tool. And by the way, don't worry, guys. Once we're done with this infrastructure design, from next week, we'll start implementing these technologies, and we'll start putting them together and see how they all connect. Okay. But for now, we're talking about it from a design perspective. And this Elasticsearch or Grafana or Prometheus, the question is, we've spun up an Ubuntu instance or Red Hat that we're going to use to install services. Now, when it's time to install the services, how will they go to the internet to download packages, right? And that's where NAT Gateway comes in. Let's see if we can have a logo on icon for it. So we have VPC NAT Gateway. Okay, so that's it. We can just bring that here. So let me reduce the size. Now, remember when we had this, it was for the internet gateway. For NAT gateway, let me just this and drag it down. What we're saying is traffic out to the internet. So NAT gateway is used for when we want to be able to go through the internet. And remember, the only subnet that has access to the internet is the public subnet. This is a private subnet. It has no route to the internet. So what we need to do in this case to ensure that this still has access to the internet, even though a hacker cannot get to it from the internet, is to put NAT gateway in the mix. And we're still going to use this route table. So what we're going to do in this case is we're going to create a NAT gateway, okay, which is also going to be in the public subnet. So we just put it somewhere here in the public subnet. Because it's in the public subnet, what we need to do is to update this route table that says that this subnet is going to be able to access the internet through this subnet only when it comes to going outside. Okay, internet gateway has to do with both inbound and outbound. So you can go out to the internet and back into the internet. And this subnet has a routing configuration, all right, that allows it to go in and out of the internet. Okay, so what we're going to do is let's just duplicate this. Okay, so we'll have a route table here. Okay, and this route table, what we would do is we'll just find a way to put an arrow to point to this NAT gateway. Okay, just to show that we have this NAT gateway connected to this. Let me make sure that it's actually pointing to this. Let me try it again. Okay. All right. This makes more sense. Yeah. Okay. So this routes table for this subnet, okay, it's basically saying that, okay, we have a routing table with a routing configuration that helps us to go to the internet through a NAT gateway. And NAT gateways only deals with the outbound. In the case of internet gateway, it has to do with in and out, but we don't care about inbound for our private subnet. Okay, we only care about outbound. So any service that needs to go to the internet through from our private subnet will have to go based on the routing configuration that has been set in the route table. Okay. And with that being set, it knows that it needs to go through this channel to then go to the internet. And, let's say it's pointing to, let's say if you want to download Nginx download. Okay. So these are the repository over the internet. And for, let's say, this is for Windows. These are all Windows. Okay. Without spending too much time trying to figure out whether Linux or whatever, this is like, let me see if we can even hit this. Okay, good. So what's this? Is this okay? So, well, as you can see, this is trying to download already. So this is just a simulation to show you that anytime you want to download something, it goes to some endpoint. So assuming this is the endpoint we need to go to, that's where it needs to go to fetch the package and install it. Okay, without a route to the internet, we won't be able to access it and download it. And it's not just for Nginx, for whatever it is, that we need to download. And there's always going to be a need to download things on our servers, right? So whether it's Nginx, whether it's HTOP or any of the tools that we need to work on our server, imagine if you need to configure LVM on this server, right? You need to download the LVM package, right? And without a route to the internet, we won't be able to do that. And that's what we're talking about here. So our architecture needs to cater for things like this. Okay, cool. Mukhtar is asking a question. I just want to quickly read that out first of all and see if it's something I need to answer. Still thinking about how we could use NACL for added security and how we can mitigate having conflicting permissions between NACL and security group. So NACL rules operate at the subnet level and of course get evaluated before security groups, which operate at the instance level. So everything you've said so far is correct. For my resource in the public subnet, how then do I screen out certain IPs on the NACL level when I do not have an idea of the IP of the bad guys? Considering I intend to open up my resource in the public subnet to the public, which is 0.0.0.0/0. So, Mukta, if I understand you correctly, what you're saying here is how can you leverage the use of NACL when you don't know the address of those whom you want to restrict access? Because obviously, if you open up to the internet 0.0.0/0, then obviously there is no NACL in place. You literally have access. You literally open up everyone, right? So, basically what you're doing here is, first of all, like I said, the use case here is focusing more on the tooling infrastructure, in which in this case, we know exactly who needs to access this subnet. Okay, this is for our internal use. We know that our private data center, which is our engineers, when they come to the office, that's the only time they can access this. Okay, if, for example, because obviously now everyone is working from home, and if you want to work from home and access this, then you would have your VPN configuration on your laptop, which essentially means that you're connecting to the private data center. And what this infrastructure is going to see is the IP address of your data center, not from your home computer. Okay, so that way you're still able to access it. And obviously, you don't know the IP address of the hacker. You don't care about it. What you care about is the one that you know, which is coming from your data center that you have whitelisted. So what we're doing here is we're whitelisting, we're whitelisting what we know about. Okay. But you can't open it up to the entire internet and still expect these guys not to come. So if your desire is to open it up to the entire internet, because this is not for tooling, maybe it's for a business application like Diary.io, for example, we want everyone all over the world to access us and consume our services, right? We cannot use NACL in this instance because we don't know who needs to access us. Okay, so we're going to have to use other means to protect our services. Okay, and that's why we have, we have security group, we have many other things that we can use to protect ourselves. So that's basically what's going on here. So this NACL is best for use cases when you know who you want to whitelist. Okay, all right, I hope that answers that question. Okay, so now that we know how to go to the internet, let's see what we have next from our questioning. We can then go into the compiler. And by the way, this is not the end of the questions. There could be potentially much more questions. Okay, there could be more questions, and when you join an organization and you're going through a design phase, most of these questions will come from discussions. You're discussing with users, you're discussing with stakeholders, your business analyst is gathering requirements. A lot of these things will start coming out, and you just want to be attentive enough to start pinning down some of those questions as you go along. And as you're asking those questions, you start thinking about the services available in AWS that allows you to make the solution available. So again, for security and networking, there could be a lot more, right? So if any one of you has more questions that we can add to this, by all means, please put it in the chat box, or you can unmute yourself and recommend, and we can add it to it, and we can even try to deliberate on it and say, okay, how will we be able to implement something to address that question that you've raised? Okay, so that's a takeaway task for you guys. So before we end this session today, try to start thinking through what sort of question. All right, so let's go to the compute layer. So how will the servers cope with increased workload? So what we're saying here is, for this type of tooling, it's kind of deterministic in the sense that we sort of know how many users is going to use the service. So honestly, scalability is not going to be too much of a concern. But if this was for our business application, then this will be a great deal of concern that we'll have to deal with. And that's because we don't know whether our product is going to grow like that or not, right? So because we need to think about whether it's going to grow fast or when it's going to grow fast, and things like that, we have to think about scalability. All right. And so for that reason, we still have to think about scale. So for the sake of, considering scale, let's still talk about it, even though we're still dealing with our tooling architecture. Okay. So one of the ways that we can handle scale is through load balancing and auto scaling. Okay. So let's start with load balancing, first of all. So let's say, obviously, our engineers, the use case we'll talk about previously was SSH, they want to SSH into it. But the other use case is if they need to go to Jenkins, on the browser, and run jobs and city jobs and all that, that doesn't require SSH. That's going to go through HTTPS, right? So for that reason, they're not going to go through to the bastion or the instance connector. What they're going to need to go through is the load balancer. Okay, so let's see if we have load balancer. Okay, well, it's not coming up, but I do know that there is ALB. Oops, there is no ALB logo, but let me see. Oops, it's not there. Okay, let me see. AWS load balancer. I'm surprised. I thought there was. But anyway, since there isn't, that's fine. It's not the end of the world. We can always make do with something. So we can use all these icons here. All right, so let's talk about this for a bit. And this is where the OSI model thing that I shared yesterday comes in, where it's important for you to understand it. Before we go into that, I think someone has raised another question. I think this is coming from Lawal. From what I understand, most of our web server will be in the private subnet. Only our load balancer will be in the public subnet. That's right. So the load balancer will be available for everyone, and the load balancer will route requests to the web server and databases in the private subnet. Okay, that's fine. I'm trying to understand. Okay, I think you're responding to the existing conversation around network access control list. So everything you said, Lawa, is correct. I'm just trying to figure out how that relates to the NACL. Jumoke is saying, I didn't get the takeaway question. I think we must have lost you there. So maybe when you watch this video again, it will make more sense to you. Please kindly differentiate between SSH access and VPN access. Okay, that's better. Okay, that's a good question. So VPN. Okay, so actually, let's start from SSH first of all. You know, I'm sure you know SSH first of all. So Bakari, please let me know, because if you're on this class, it means you have worked with SSH at one point or the other. Yes, good. So it's the protocol that you use from your laptop to go into a remote server, and then you can work on that server, right? But think about it this way. If you're working for a company, let's say you're working for Central Bank. Now, this will immediately, sound a security alarm in your head. Like Central Bank, like it has to be really, really secure, right? So let's assume this is for Central Bank. And do you think that working with Central Bank, you can just go into, assuming they have their services running in AWS, do you think you can just go into their service in AWS, take the public IP address of their server, put it on your laptop, put SSH, and put the IP address, Ubuntu, and then it just connects to the server like that? Do you really think that would be the case? Definitely not. I mean, if that were the case, then central bank wouldn't be secure, right? Like, they hold a lot of data about a lot of people. They hold the treasury of the entire country. So it has to be really secure. And so their servers will not be accessible like that over the internet. Because what you used to do when you're practicing your SSH is just accessible over the internet. You can just put it, in fact, if you give me the IP address, I can access the server just the same way you can access the server. And that shouldn't be the case. It should only be accessible to people that need access to it. The engineers that have been hired by the company, they've either gone through some kind of security clearance, they know who they are, and for that reason, they've been given access to get onto those servers. Okay. Now, if that engineer goes into the central bank office, the physical office, okay, and then they go in with a laptop and they connect the laptop with a LAN cable to access that network, what it means is that within that network, they are, when you connect that LAN cable, it basically means that every computer within that private data center, you can access it. It's within that particular network. Okay. Or when you get into that place, you connect over Wi-Fi. Okay. And then your network becomes accessible, within that network. Now, let's now say that within this network, you now want to access services inside AWS, okay? And it has to go through a private tunnel, okay? No internet whatsoever, because there are use cases of architecture that will completely not require internet gateway neither will it require a NAT gateway, which means it's completely blocking the internet, completely. So if it's blocking the internet completely, how then are you possibly going to be able to access AWS when there is no internet? Okay, and that's where VPN comes in. So with VPN, there are configurations that needs to happen. So there's something called the customer gateway. There is a VPN configuration. AWS will provide some VPN configuration file that you need to take onto your private data center. You install a few things in there, and after all that configuration is done, what it does is it opens up a private channel that allows you to go still over the internet to access AWS. But you see, that channel is going to be enclosed. Okay, it's going to still use the internet, but it's going to be completely enclosed, and no one from outside will be able to break into it. It's going to be encrypted, it's going to be private, and your SSH will still work over that private tunnel to access it. So that's basically the differences between the SSH. So SSH is just a protocol that allows you to go through, but VPN is the security layer that helps you to shield, you from the internet to allow you to get through. I hope that makes sense. Okay. All right. So now that we have that out of the way, so we're talking about load balancer. So how do we get load balancer in the mix? So assuming we want to go to Jenkins.tooling.io through the load balancer. Okay, so let's assume this is a load balancer. So I'm going to in this and just say, okay, so before we do this, first of all, let's just tell you, with load balancing in AWS, there are different types of load balancers. A few years ago, there was only one type, and that's what is now called the classic load balancer. Then it was called a elastic load balancer, which means it's elastic, it's a load balancer, you can use it, it's highly scalable, and it operates on both the layer 4 and the layer 7 OSI model. So if you watch the OSI model, you understand what I'm talking about. So that elastic load balancer, which is now classic, was operating at both layer 4 and layer 7. Okay, so the question is, when it comes to using load balancers, you have to decide, well, which load balancer am I going to use? Do I need the classic load balancer? Do I need the network load balancer? Or do I need the application load balancer? Now, there's a new one. I think it's called a gateway load balancer. I don't have a use case for that. It's for special devices. I haven't actually used it personally myself. But the most common ones that you come across are those three that I've just mentioned, which is the classic, the network, and the application load balancer. Now, with these three, and by the way, this is a common interview question. You really have to understand the differences between them and how to make a decision to use either of them. Now, let's quickly eliminate the elastic load balancer or the classic load balancer, because that AWS recommends not to use it, especially for new projects like this. So if this is a new project and we're trying to build something out new, that automatically eliminates the classic load balancer, because even AWS says we shouldn't use it. But back in the days, that was the only one available. If that is what your infrastructure was based on, then that's the use case that still makes it possible for you to still use classic load balancer, because some people still have their infrastructure relying on that. All right, so that leaves us with the NLB and the ALB. So we have the NLB and we have the ALB. So the question is, for this architecture, which one should we use? Actually, now it's time for me to ask you guys questions. Should we use NLB or ALB? So for now, I'm just going to write NLB just for the sake of putting something in here. Okay, I'll just put it here. All right, so this is the time you can unmute yourself and talk to me. So now what we need is load balancer to do is basically to access. Okay, so oops. So this is for let's say we have what's it called? Elasticsearch. Oops. I actually wanted to go like that. So let me try. So guys, I'm waiting for you guys. Any volunteers who would like to talk to me about which load balancer should we use and why? Okay, so we have, so let me just put it here, or ALB. So we need a load balancer that will come, actually, let me remove our hacker. So we don't need our hacker to be in the mix. So this is coming from our engineers, okay? And they hit, whether they're trying to go to Bastion, okay, they hit the load balancer, but this is the destination, Elasticsearch. So let me put it here. ELK, all right? So tell me, I see a lot of people saying ALB, 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 but why? Okay, so Jumoke says ALB because we're working on different industries. Well, okay, well, I mean, this is just for our tool. It doesn't matter. It has nothing to do with the industry, whether it's healthcare, fintech, whatever. It doesn't really matter. This is just an infrastructure so that we can have our tools available. So I'm going to need one of you guys, to unmute yourself and tell me why you think we should use ALB. I see everyone, well, not everyone, a lot of people saying ALB, but why? Why would you decide to use ALB? ALB because we're dealing with different applications. So what are the different applications? I mean, okay, so let me just duplicate this, because potentially we could also have Grafana, right? So you're saying because, we need to talk to both Grafana, ALK, right? And then someone says ALB because we're using HTTP, HTTPS. Okay, all right. Okay, so let's begin to explore one at a time. So let's assume we made the decision to go for NLB. I'm not saying that's the correct one, but I'm just saying we go through NLB. So one thing that will help us here is to understand the features of the different types of the load balancers. So I've actually documented it here in this document. So load balancer. Now there's a lot of features. I've just put the ones that are most important for our understanding on this session. Okay. I've also put the the features for the application load balancer. So let's go through them one at a time. All right. So the first one, IP-based traffic routing. So NLB operates at the transport layer 4 of the OSI model. So I believe you've watched the OSI model video. So if you have, thumbs up to you. And with that, you will really understand that, there are different layers of communication, and the network load balancer operates at the IPv4 layer 4 level, rather. Okay, the layer 4 level. So this is a very, 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 very crucial component when you're talking about the different types of load balancers. Okay, so this operates at layer 4, and this means that NLB can distribute traffic directly to backend instances based on their IP addresses. So it's layer 4, it works based on the IP addresses. So it can communicate directly to servers as long as they have IP address, and that's how network load balancer works. Static IP address for load balancing. So what you need to do is, as we are talking about this, you would also be asking yourself the question, okay, for the architecture we're building, because it operates at layer 4 and it routes traffic based on IP address, is that a reason to choose this load balancer? So that's how you're going to be thinking about it. So is this enough reason to choose this? Okay, so I mean, are we trying to route traffic based on IP address? So we're going to our browser, we're putting HTTPS. Is that a reason to go for NLB? Because it routes traffic on IP address, and we're not putting IP address in the browser. What we're putting is some HTTPS, HTTP protocol. And for me, immediately, it just eliminates network load balancer, but we won't stop right there. We still have to evaluate a few other things. Now, static IP address for load balancer. So NLB provides a static IP address as the entry point for your application. So if you have a use case to have static IP address, then network load balancer is going to be a reason to want to choose it. So this is important when deploying services like Elasticsearch, for example, as it ensures consistent access even if backend instances change. Okay, so is that a good reason enough to want to use a network load balancer? So it says with a network load balancer, we're going to have a static IP address, and because services would need to communicate, we need to use a static IP. But again, it's not really a strong reason here, because it's not like we're putting IP address in the browser. We're actually putting the name of the service in the browser. So again, it's a no for me. Now, high throughput and low latency. NLB is designed for high throughput and low latency, is making it suitable for data-intensive workloads like Elasticsearch, which is good. But the truth is, ALB is designed for high throughput and low latency as well. All right, so health checks and failover. NLB performs health checks on backend instances to ensure they are healthy before routing traffic to them. Okay. Again, ALB has health checks configuration as well. Cross-zone load balancing. So NLB distributes traffic evenly across instances in multiple availability zones. Does ALB do that as well? So don't forget, ultimately, we're going to duplicate this, and then we're going to have another availability zone, which means that this same load balancer can route traffic here and can also route traffic there. Okay. Then preservation of the source IP. So NLB can preserve the original source IP address of the client, which is beneficial for login and security purposes. So remember, with Elasticsearch, what we're trying to do is to ensure we're able to log everything. So if someone is trying to reach our services and we need to be able to track which IP address is accessing us, especially if there's like a DDoS attack or someone is trying to bring our systems down. We want to know where that is coming from, and that's the client IP. So because it's able to preserve the source IP, okay, it's a good use case, because what it means here is, when you provision a load balancer like this within VPC, remember this VPC has its own CIDR. Anytime you provision a network, whether it's a network or application load balancer, it will have its own IP address, which is going to come from the VPC IP. Now, if you try to hit this load balancer and the backend service that is routing traffic to, if it's not preserving the client's IP, what's going to happen is this service right here is not going to see the originating IP address. It's only going to see the IP address of the load balancer, because that's the one that is communicating with it. Okay. But if it has the configuration to preserve the client IP, it's able to then let it know that, well, actually, it's coming from this person, even though I have my own IP address. Okay. So in the case of application load balancer, that's where you have this extra header configuration where you say X forwarded. When you see things like that, it basically means that the IP address of where it's coming from is being forwarded to the upstream. Okay, so those are the features of NLB. Again, do you guys still think that NLB is not our ideal load balancer in this case? Okay, well, I wouldn't blame you if you say yes, because so far it sounds like ALB will be the ideal choice here, because first of all, it operates at the layer 7 of the traffic routing, which means that it can route traffic based on specific content of the HTTP/HTTPS request. such as URL paths or query strings and all that. So if you think about it, we want the load balancer because we're not going to provision multiple load balancers. Okay, we're only going to use this one load balancer to talk to whether it's Grafana, to Elasticsearch, or whatever service that we deploy in this infrastructure. And so we're able to do configurations such that if the header says that it requires to go to Jenkins, it knows that it has to go to Jenkins, although we haven't put Jenkins here. If it sees that it has to go to Elasticsearch or Grafana, basically it has that intelligence to route traffic depending on where we want it to go, because it's operating at the HTTPS layer 7. And every time you put a request in the browser, like let's try to put a request here. So if I do curl to https://array.io, and by the way, I need to do -v so that it returns a verbose data. Now you can see it's returning all this data for our website, but what I want to do is go all the way up so that we can see some metadata. Okay, so one of the metadata I'm interested in here, let me see if we have it. Oh, this one right here, host. So it has this host header, okay? And this host header is what the ALB can actually use to determine where the user intends to go. So imagine if we had a load balancer that is being used for multiple services. If there's another service in our infrastructure that says something like tooling.io, if the host says tooling.io, it knows that it wouldn't send it to the servers that is servicing the .io app. It's actually going to route it to the relevant service, whether it's for Jenkins or for Grafana or whatever it is. I hope that makes sense. So that's one of the powers that you can actually use and benefit from the ALB. So to answer this question right here, where is it? Regarding how will servers, how will servers cope with increased workload? But what we're trying to answer here is which type of load balancer to use. So which type of load balancer? So we also have to answer that question. So even though we know we have to use a load balancer, but which one? Okay, so that answers that. I hope that makes sense. Any questions before we quickly go to auto scaling and then we finalize with the data layer? Okay. Jude is asking, could we have the slides for the load balancer? Which slides are you talking about? Are you talking about the one we used in the previous class, which is this one? If that's the case, then it's right here at the top of this document. So if the documents that you're requesting for is this one, then you already have it. But for today's class, I'm just going to name it, and then I'll share this by the end of the class today so that you can use it. Okay, and then these are the other features of the application load balancer. Path-based routing, HTTP/HTTPS, cross-zone load balancing, content-based routing, all that makes it possible for us to then use ALB. So now it makes it for ALB. But let's also talk about the use case for an NLB. Okay, I mean, we've talked about it. Now in this architecture, can somebody tell me what is the use case for NLB here? Because there is still a use case for NLB. So I'll need someone to tell me, where do you think we can actually put an NLB? I'm interested to know, because that will help me to know whether or not you guys are following along and if you truly understand what we're doing here. Anyone? Someone says IP routing. Yes, IP routing, but for what service? What service in particular? We have a number of services that we've configured here, but which of the services here will be ideal to be used for NLB? So Chijundu has mentioned Bastion host. Does anybody agree with that? I'm not sure about that, but anybody, you can actually unmute yourself. Bamidele says yes. Okay. And Emmanuel also says yes. Okay, good. That makes sense. So I'm glad you said that because it shows that you are actually following along. What's Shay says? Shay says that will be useful for private data center communication with the ELK Grafana. Shay, you're wrong because we're still talking about the ELK Grafana because, like we said before, that is going through. We're gonna have to put in the browser to access our ELK or Grafana. And using ALB, we can route it to multiple services, okay? And that operates on layer 7. But for our Bastion, so let's put this back to Bastion or our proxy server. Okay, these operate at the IP layer. Okay, these operate at the IP layer because it's for IP routing. The Bastion server, you want to SSH into it. Now, let's assume that, let me see if I can duplicate this. Okay, no. Okay, so that. I want to see if I can quickly duplicate this. Okay, so I've selected all of that. Let me group them together and duplicate them. Okay, so we have this now. So what this means is, so let me ungroup. Can I actually ungroup this? Is there an option there to ungroup? No. Okay, well, I should be able to ungroup this one, definitely. Okay, so I can ungroup this. So what I'll do is, because I couldn't ungroup that one, what I'll do is I'll just put this EUS2B so that this is 2A to represent the two different data centers. And this one, I can just give this maybe 2, okay? I hope you're following along and you understand what I'm trying to do so that you don't seem confused, right? So ultimately, we have 2 data centers, both replicating for the sake of redundancy and high availability, so that if this goes down, this continues to service the request, right? And we have the Bastion here, we also have Bastion here. But we're not going to the browser to put the specific IP address for this Bastion, okay? What we want to go, oh, sorry, I beg your pardon, I'll take that back. So I didn't mean to say browser, your terminal, because you're doing SSH, so don't get confused, okay? So for Bastion, you need to SSH into the server, right? So what you want to be able to do is ultimately come to your terminal like this, and you want to be able to do something like SSH. Okay, 1 second, please. I'm just going to mute for a second. Never mind. All right. So what you want to do, let me increase the size. Okay. So SSH, okay, let's say -I, which is, let's say you want to, oops. Okay. And that's our private key, right? And then you want to say Ubuntu. Well, let's assume the name of the engineer right here is Peter. So this is Peter trying to connect to our server. And then he wants to go to the Bastion, and he goes bastion.tooling.dare.io. He wants to connect to this server, right? Peter needs to connect to this server over SSH. So if you remember, and of course you've been working with SSH for some time now, so you understand, you're familiar with this connection string, and you know that with that, you're going to be ultimately able to connect to the server, right? But in this case, the same URL can go to any of these servers. So in this case, you don't need an NLB because the traffic routing is going to happen on the IP layer, not on some HTTP, HTTPS, host headers, and all that. Okay. So what will happen here is our engineer can go through NLP and then ultimately go either here or here. That's what we're saying. So NLB fits for this use case right here because you can use it to connect to either of these. So what happens is NLB would always resolve this bastion or tooling to any of these IP areas, whichever one is available. And because it's a bastion, it's not a server where you keep data. It's just a hop onto the next server. So it doesn't matter which one you get onto. It's not a server where you're supposed to keep things on, where you'll be concerned that, oh, what if I saved my file here and then the next time it routes me to connect here, I won't be able to see my file again. No. I mean, that shouldn't be the case for Bastion Edition Hub. But you never know. Maybe there's a use case because you see, there is no right or wrong to these things, okay? But it's possible that even your bastion, you have a use case that, well, you want to be able to maintain data such that anytime you go back to the server, you've created files on there and you still want to be able to use the file. That's fine, no problem. There's still a solution for that. Now, let me ask you guys, how do you think we will solve that problem if that was the solution, the use case? Well, this is how you're going to be able to make decisions when these use cases come up. And you can help your team to say, oh, well, if that's what we want, then this is how we're going to achieve it. So I'm throwing it out there to every one of you guys. If that was the use case for our bastion, what do you think we can put in here to make that happen? Tell me. Anyone wants to try? Okay. So Peter connects to this and he's able to access the bastion quite all right, but he needs to be able to ensure that anytime he tries to log on again, he goes onto this server, the same data that he stored here, he's still able to access it, even though he's now connected to another server. What do we do? Okay. Someone is saying we should have an EFS mount point, and Mokhtar has put a thumbs up to say, yes, that's what we should do. Absolutely. So I agree with you. So you can implement EFS mount point and have the mount points on both of them so that whenever you connect to either of them, you know, your data remains. So you can see this is how you're able to then continue to design an infrastructure. So if that were your use case, then you can say, okay, well, we probably want to have another subnet, which is going to be for our data layer. And then you can increase this, create a new subnet, and then have your EFS there and then connect to it and make sure that, you know, there's a mount. So that's how you get to design infrastructures and help your company. All right, so let's see if we can quickly wrap things up quickly. And so we've taken, okay, so next thing is auto scaling. All right, so with auto scaling, okay, what are we saying? Well, in this case, we only have one server for ELK or Grafana. But when traffic or demand increases, how do we ensure that, you know, one server can turn to two, can three, turn to four, five, you know, and we can dynamically scale like that based on scaling events like CPU spike, memory spike, or whatever. Okay. And that's where auto scaling comes in. Okay. So just to clean things up a little bit and not make this messy. So, you know, there's that possibility for your designs to become messy as you go along. So what you can do is you can just, let's remove this, remove all that. Okay. And what we can do is we can just have something like that in between. Okay. We can give it a color. Let's give it a nice pink right there. All right. And then we can expand that. Right. So these represent auto scaling. So we can just put text in there to say this is what auto scaling. Okay. So we have auto scaling. And then you can then put your EC2. So what you can say here is rather than say Elasticsearch, Grafana, whatever, this EC2 can just represent, whatever service you put in here to say, you have autoscaling for each of your services. So Elasticsearch will have its own autoscaling, and it will be able to, your ALB will be able to take the traffic and then point it all the way down to your autoscaling group. Okay. For Grafana, same thing for Elk, same thing for Jenkins and whatever you want to do. Okay. If you like, you can maybe just, if you want to be a lot more granular, you can just, do something like this and duplicate it and put another one and say, okay, auto scaling for Grafana, auto scaling for Elasticsearch, but you have to be careful because, your architecture can become a lot messy. So it doesn't really matter as long as this design is well communicated with whoever is using your infrastructure and they understand, and that's all that matters. So there's no right or wrong answer to how you design your infrastructure. Like I showed you just now, we have some really nice, amazing designs that's been done by some of you guys. This is one from Chinjundu. I hope I mentioned that correctly. Okay. Did anyone else try? Okay, no one else. Right. Okay. So that was from Chinjundu. This was from Mitchell, which is also very nice. And I think what you guys also did, talk about organizational units and all that. Okay, separating the environment, which is fantastic. All right, cool. What else do we have? Data layer. So how will we store and persist user data? So we have databases, network file system, EFS. We talk about EFS the other time, static files, S3, whatever. So what we can do is, if we need to use any of those, it's just as simple as creating a new subnet, putting a new subnet here. Okay. And then just give it, this is our data layer. Data layer. Okay. And then you can put your S3. Actually, S3 does not work specifically with subnet per se. It's a global service, but something like EFS, for example. Let me see. Okay, this is EFS, so you can put EFS here. We needed EFS. If let's say you're going to use Redis, okay. Okay, this is RDS, right? So if we need to use RDS, which is database as a service, whether it's MySQL, SQL Server, Oracle, whatever, Memcache, whatever. So anything that has to do with database that is storing data, right? DynamoDB, which is a document store, like MongoDB. For those of you who are developers and have worked with MongoDB, you would understand this. So this is a document DB. Anything that has to do with the data, you just put it in its own data center. And it's just a nice way of separating compute from data, from, proxies, and you can replicate that across multiple availability zones. Okay. So this represents our tooling. This is an ugly architecture, but what matters most is you understand the concept. Okay. So this is one. Now, the next thing is we have our tooling, but we also have our business applications that needs to connect. So let's say this is our dev environment, okay? And what I would expect from you guys is to design similar architecture like that for your dev, for your, dev, prod, all the way to production, pre-prod and all that will pretty much be similar, okay? But what we're trying to simulate here is this. You see, this tooling could be an environment based on AWS account. This could be an AWS account on its own where it's completely standing alone, an entire account with its own VPC and all that, okay? And this could be another AWS account for dev. And then you can have, to keep it simple, let's just have dev and production. Okay. And this is production. So you could have more than two environments, you can have multiple environments. It all depends. Okay. So you can ignore the bell. Someone's gonna get that. All right. So let me just make that big a little bit. So we have Elasticsearch, we have Grafana. That with Elasticsearch, we need to ship our logs into it. With Grafana, we need to ship our metrics into it, from dev, from production, and all that. How do we connect these two together and these two? And the other thing is, it's possible we have third-party companies, maybe our software is, maybe it's a fintech software that other companies rely on. I'll give you an example. So let's say, it's possible for you to buy recharge cards from your mobile telephone, okay? And this recharge card, in some cases, you go to your banking application and you actually purchase the recharge card from there. So that means if you're using maybe GT Bank or Zenith Bank or Barclays or wherever, you can go into your banking application and then you can purchase a recharge card for your telephone device. And what that means is there is some integration between your bank and the telecom provider. So if this were to be a company like that you're working for, maybe you're working for either side of the company, maybe you're working for the bank or you're working for the telecom, there's need to integrate services one way or the other. So for applications to integrate, it could happen on an API layer, which is HTTP, HTTPS, or it could also be on the layer 4 layer as well, which means that servers or IP addresses need to actually communicate with together. So depending on the kind of communication, you have to also determine how your infrastructure will be able to communicate together. So you can communicate and allow access on a security group layer. You can also communicate and connect them together, from a VPC pairing perspective, especially if the other company is using AWS as well. You can, put some VPC pairing solution together. Another use case is, let's say you're working for a company, maybe a small, what's it called, like a microfinance bank, which has recently been acquired by a bigger bank. Okay, and both banks were operating on AWS together, okay, or Azure. Now, a use case could be, well, now these two establishments have come together, they need to be able to integrate their services, even though they're in separate AWS accounts. You now have to start thinking of how do you integrate them together, and these are example of what we are calling, the third parties. Okay. So this is a third party. So whichever the case is, so we have our dev environment, we have our production environment, and we also have our third party. So this third party will also have their own production and dev as well. So that's the interesting thing here. So this third party, their dev environment needs to be connected to our own dev environment. Okay. Let's want it to be straight. It's not straight. Okay. Anyway, you can ignore that. So the production, they need to also connect together. Prod to prod, dev to dev, and whatever, as many environments as there are, you need to connect them together somehow. So you can put in together what is called a VPC pairing. Let me just make it big so you can see what's going on. So VPC pairing here. So that production to production, third party can connect there, and you can also have VPC pairing here. Now, between our dev and production, you have to also, between our dev and production, first of all, is there need to connect them together. I don't think we do, okay? Because obviously, if someone gains access to your dev, you don't want them to access your production. So they have to be completely separate, okay? So for our tooling, okay, if we need to configure monitoring and logging for our dev, then we need to find a way to connect our dev with tooling, okay? And the same thing, our production, okay? But in most cases, what you would see is it's possible to have a tooling environment for dev as well. So rather than connect these to this particular tooling, what you would see in most cases is even this tooling has its own dev environment. So everything that we've deployed in tooling here, so this is tooling dev. So let me just make it a little bit big. You can see, so everything here, it has its own tooling. Okay. So what's going to happen is tooling dev connects to dev here, so that when we're still developing our tooling, there is possible that we want to create dashboards, we want to try things out. We're not going to be tampering with our production tooling. We'll test that out on our tooling dev, and then we'll connect our other dev environments to this tooling dev, so we have a complete isolation like that. So these also needs to be able to connect to this, and we can have VPC pairing as well to get them working together. Okay. Now, there's another concept called the transit gateway, which when pairing is becoming complex, it makes sense to use transit gateway, which basically also allows private connectivity between accounts or VPCs. But the problem with one of the problem with VPC pairing is the fact that you pair. Let's focus on production for a second. So these are tooling accounts or VPC, okay? And we have VPC pairing to our production. We also have VPC pairing to our third party. The fact that there's VPC pairing between tooling and production here does not mean that if you're here, you can, by virtue of this pairing, access this. You can't, okay? And you can imagine if things become complex and we're having a lot of different environments and VPCs that we need to connect together, we have to configure separate VPC pairing configurations, to bring services together, and it becomes really complex. So Transit Gateway solves that because it's a seamless way to connect multiple services together, no matter how complex they are, okay? And it makes life easy, even from administrative purposes. All right. So that's that. So again, environments can be separated by VPC. It's possible to have one VPC like this and have different subnets, and each subnet represents an environment. That's another thing. So rather than spend money having different VPCs running multiple services, because remember, each VPC will then have several availability zones and subnets, and the more services you provision, the more the cost and everything. So if you want to keep the cost down, you can actually have everything within one VPC and separate them by subnet, and use things like NACL security groups to separate them. That has its own pros and cons. Yes, it's going to be cheap, not too expensive. However, you can imagine security concerns, because if someone gets into this environment, obviously, you can get easily compromised. Okay, so this is where we're going to stop today. Any questions? Let's begin to take questions, and I hope today's class has been quite informative to you.
Hello, Dari. I have something to say.
Yes.
Oh, so sorry. Yeah, it was when you were talking about the network load balancer regarding the patient. Then when you were like, if you want to access it, services on the subnet, let's say for instance subnet A and subnet B, and probably the services is gone on the subnet A. If the person will be afraid not having the services or his files on subnet B, you said you now ask a question, what can you use to mitigate that? Then somebody said EFS, which is Elastic File System. I was thinking it was going to be NFS, Network File System, because in one of the notes you taught us, you know, when we're working on the instances, so we actually use the NFS in communication of the instance. So whatever file you have in one of the instance, you have in another instance. So all the services that is on the subnet, they're actually instances holding them. So obviously it's actually NFS that would have been the best system to use instead of EFS.
Okay. So let me ask you, first of all, what's your understanding of EFS?
EFS is Elastic File System. Is actually a storage that as well help the sharing of files in instances, in different instances.
And how does it differ from NFS?
Because NFS is like a it's a network file system. It's like it works like Elastic File System is actually working on instance himself. That is related to the instance himself. But NFS is actually sharing of files among instances.
Okay, so I think that's where your confusion came from. So you're wrong with your understanding of what EFS is. Okay, and that I see where your misunderstanding is coming from. So basically, you can think of EFS as NFS as a service in AWS. Okay, so rather than you creating a server, installing NFS, configuring NFS, updating the FS tab, and doing all those things, okay? With EFS, you don't have to spin up a server and do all that configuration. In fact, installing and configuring NFS is not even the problem. The problem is actually maintaining it, creating a high availability for it. Because if one NFS instance goes down, how do you ensure that data is available to all the servers that have mounted mount point to it? Okay, and also scaling it. If data fills up, how do you scale it? Do you then go in and start configuring more LVMs and adding more volumes and doing all those kind of things? So, the problem is not even installing it, but the ongoing maintenance of it. And that's where EFS comes in. So EFS is basically NFS as a service. It's just a service provided by AWS that enables you to have the same NFS solution, but this time around, it's a managed service. And it's using the NFS protocol. So the same way you would interact with NFS, you can also interact with EFS and mount it and forget about administration. So you're still right by saying we can use NFS, except that you can also use EFS, especially if you don't want to do the management and administration of the NFS server. Does that make sense?
Yes, sir, it does. So thank you so much.
All right, good. Thank you. Any other questions? All right, good. So I hope today's class has been informative for you guys. So next week, we're going to now start our implementation. So what we're going to do, first of all, we're going to try to install Elasticsearch, Kibana, Logstash, Grafana. What I would like us to do is to have those tooling components up and running, and then maybe the week after we implement our business applications, and then show how they send logs. We'll do VPC pairing connection between them, and get that out of the way, so that once we have that sort of understanding, we can then move on to containerization and try to replicate the same thing in Kubernetes and stuff. And I want us to quickly get to the point where we really understand how things work in the cloud, how to automate some of these things with Terraform. We'll go through all those kind of things, and ultimately we'll start getting ready to start going for interviews. So I hope that makes sense. I hope you guys are excited, and if there are no questions, I'll see you next week. And by the way, for homework, takeaway homework, please pay attention to the Slack channel, because Chinwe is going to reach out and share with you your task for the week, your quiz for the week, whatever it is that we want you to do for the week, and the courses and things that we want you to learn before the next class, so that it will help you understand it, especially as we go through the hands-on implementation. Okay. All right then. Enjoy the rest of the weekend. Bye.